Hello, everybody. In this video, I'm going to go over Unit 3 review, and Unit 3 was on solving quadratics. And in this unit, we solved using various ways, from factoring to graphing to completing the square, solving by taking the square root, by using the quadratic formula or using the quadratic formula. And then we had some applications, word problem applications with quadratics. So I'm going to go over a couple problems from each type of solving, starting with solving by factoring, which was lesson 3A. So let's start here with, an equation that is not factored. Let's say number 7. So if we start with number 7, the question says 8n squared minus 6n equals to -1. So before you factor, you need to make sure that your function or your equation is in standard form, which means you need to add 1 to both sides, right? If you add 1 here, you add 1 here. So remember, before you factor, you need ax squared plus bx plus c equal to 0. You can't factor before you have that. Now you try to factor. So in this case, we can factor using different methods. One of the methods that I notice most students like is grouping. So here we can use the X method or the AC method as we know it. And the question becomes, what two numbers multiply to 8 add up to -6? We know 2 and 4 multiply to 8, but we want the sum to be negative, so it's -2 and -4. So therefore, this becomes 8n squared minus 4n minus 2n plus 1. So technically, you're breaking the -6n into -4n and -2n. And now if you do by grouping, you can group the first two here. Yeah, that helps you factor out of 4n, leaving you with 2n minus 1. And then from these two, this looks very much like 2n minus 1, but just opposite. You have -2n plus 1. So when you see opposites here, so you see -2n plus 1 when you actually want 2n minus 1. This is an indicator that you need to factor a negative out or a -1 out. And this leaves you with 2n minus 1. Now, if you multiply back in, you will see that you'll get -2n plus 1, which is what we had in the previous step, equal to 0. But by factoring a -1 out, you just created a 2n minus 1 as a common factor, so you factor that out. Right? And by factoring the 2n minus 1 out, which is these two, technically you're factoring them out, this leaves you with 4n minus 1 as the second factor. And this is now you have two factors, their product is equal to 0. By the zero product property, if you recall, the zero product property says if a times b is equal to 0, a multiplied by b is equal to 0, that means either a is 0 or b is 0. And remember, we said or is an inclusive or in math. So that means A, B, or both of them, right, could be 0. They happen to be the 0. And this could be extended. You can do A times B times T times C, etc., right? So, but for the purpose of this, you have two factors only, so one of them must be 0. What value for n would make this 0? It's n equals 1/2. And I had also talked about this in class. There are two ways. You can either set 2n minus 1 to be equal to 0 and solve for it, which gives you, by adding 1 to both sides, you get 2n equals to 1. And therefore, by dividing by 2, then is n equal to 1/2. Or you can do the method that we talked about, which is a shortcut. You find the opposite of this divided by this. So +1/2, which is 1/2. Okay, similarly, the second solution, so that's one solution. This is one value that makes it 0. Or you can say this, or n equals 1/4. Okay, so we have two solutions, meaning this equation here, right, this quadratic, right, will cut the x-axis, or in this case, the n-axis, at two intercepts, at 2 points. Okay, we have two real values, two real solutions. And we're done for this one. Okay. Let's try another one. Let's try one that doesn't have, let's see, we can try, I mean, these are already done for you pretty much. They solved, because when you solve by factoring, you have to factor first. And here automatically they factored it for you. So for number 8, the solutions are easy. 2, x equal to 2, and x equals negative 3/2. Now, if someone had asked me in the class, could I write x equals negative 3/2 and then comma 2? That means this x value and this x value. And the answer to this is yes. Just don't put them in parentheses, right? Because that's an ordered pair. This means if you put them in parentheses, that means you're talking about x and y, and they're not. They're both x values, right? That make the y value equal to 0. So these are the answers to number this or this, basically. To number 8. For 6, real quick, again, you have to add the 8b over. And make sure when you add them, they are in this order. The b squared first, or the x squared first, then the b, and then the constant, in this order. Remember, x squared, then x, and then constant. And sometimes you may not have a constant. It depends on the situation. So here, you would say, what two numbers multiply to 7, add up to, at negative 7, sorry, add up to negative 7. Add up to 8, and 1 and 7 multiply to negative 1 and negative 7, or negative 7 and 1, or negative 1 and 7 multiply to negative 7, but do they add up to 8? They don't. So in this case, actually that was a plus 1, you see. When I dropped this down here, I wrote it as a negative 1, and that didn't work out. So that was a red flag for me. And this is a learning moment. So this should be what? This should be positive 1, because that's what it was. It was given as positive 1. So this changes the whole thing, because with negative, it was not factorable. So now we need what two numbers multiply to 7 and add up to 8, and that's pretty straightforward, 1 and 7. So you're saying technically this is 7b squared, and instead of 8b, it's 7b plus b, and then plus 1 equal to 0. Again, you can do grouping, and you could do it differently. You could say, to get 7b squared, I need 7b and b, right? You could do that, and then what two numbers multiply to 1 at the end, they're going to be 1, basically. 1 and 1. So this is going to be 7b by factored, and then b plus 1. And then here you can see b plus 1, so you can also factor 1. Always remember that when you have b plus 1, the same term, you factor a 1 out. And this becomes, again, b plus 1 is a common factor, so b plus 1 times 7b plus 1. And that's always equal to 0 here, equal to 0, carry that, right? So what are the solutions? The solutions are b equals to negative 1/7 or b equals to negative 1. Okay. So this is how solving by factoring. So you factor first, and then once you have your factors equal to 0, then one of them equal to 0, you said this or that. And let's move on to the next skill. Let's move on here to solving by graphing. Okay. When we talked about graphing, we said it would be ideal to have 5 points when you graph a problem. It's kind of nice to have 5 points and make a table of values. So let's see here. We can first, when you graph a parabola, you know the vertex is essential to a parabola, right? The vertex. And if you remember, the x value of the vertex was negative b over 2a. So you need that value first things first. So in our case, for number 1, we're doing number 1. For number 1, we know a is equal to 1. A is what's the coefficient, the leading coefficient of the equation, which is a 1. B is negative 10, and C is 24. So to find the x value of the vertex, which is negative b over 2, it's the opposite of b divided by twice a. The opposite of b is negative 10, or negative minus 10. Over 2a is twice times 1, 2 times 1, which is going to be 10 over 2, and that's 5. So the x value of the vertex is 5. That's the x value of the vertex. To find the y value of the vertex, how do you do that? You take the x value that you just found and you plug it into the equation. Now, I want to remind you of good habits, right? Good work habits to find the y value. When you plug in any value for x, erase the x, replace it with a pair of parentheses, and then plug the value in. Okay? This is a good habit that helps you avoid confusing negatives or making mistakes with negatives especially. So here it's okay. Here we have 5, and that's not a big deal. It's a positive value, so it shouldn't be problematic. But keep that habit. It's a good habit, I believe. 5 squared is 25. Minus 10 times 5 is that's negative 50. And then plus 24. So you technically have 25 plus 24, which is 49, minus 50, which is negative 1. So the x, the vertex is basically 5 comma negative 1. That's the vertex. So you on the graph, on your Cartesian plane or your xy coordinate, you go 5 to the right, 1 down. That's the vertex. Now you can, if you remember, I'd like to make a nice table of values. So the table of values goes like this. You start with you have 5 it's okay, it doesn't have to be fancy, but so in the center, right, in the middle of the table of values, you always place the ordered pair for the vertex, so the x and y values of the vertex. And then you go one value right of the x value of the vertex, and another one to the right, and one to the left, and another one to the left. And remember, we said this and that will be the same because they're symmetrical. This value and this value will be the same because they're symmetrical. So let's try this. And therefore, we have to only try one side or the other. We don't have to plug in for 3, 4, 6, and 7. We can just do it for 3 and 4. So if we plug in 4, right, f of 4, basically, we're trying to get 4. If we plug in 4, if you plug in 4 here, right, you get 4 squared minus 10 times 4, and then plus 24. And this gives us 16 minus 40 plus 24. 16 plus 24 is 40, minus 40 is 0. So 4 gives us 0. This is your x-intercept, and 6 will also be your x-intercept. 6, and it makes sense, right? Because you know your parabola has a 1 as a leading coefficient. The leading coefficient is 1, which is positive, which makes the parabola open upward. Remember the smiley face parabola when a is positive? So we expect, if your vertex is here at 5 comma negative 1, you expect it to go upward after that, and therefore it's going to cut the x-axis, and then so on. Plug in 3, you get 3 squared minus 10 times 3, and then plus 24. 3 squared is 9, minus 30 plus 24. 24 plus 9 is 33, minus 3 is positive 3. So this is going to be positive 3. 3 to the right, 3 up, and be careful here with your, always careful with the scale. Make sure you understand what your scale is. So 3 will give you 3, and 7 will give you 3. Okay, and remember, your parabola is always a smooth curve. It's not a V, it's not a sharp V, it's not an absolute value. It's a smooth curve. It's a U-shaped curve. So I'll do it this way, halfway here, and then the other half. Again, I just want to try to make it as much as of a U-shaped curve. Okay, this is how, well, this is what a parabola looks like. Don't go like this, it's wrong. And just don't, please make sure you spend a few extra seconds on graphing correctly. Okay, and also make sure your 5 points not only are stated in the table, but they're also stated and shown carefully and accurately on the graph. Okay, I want to see this on the test, on the quiz and the test. So make sure you do that. Okay, this is your function. This is x squared minus 10x plus 24. Now let's go back to, see, we front-loaded the work, and now let's answer the questions. How many solutions? The solutions are the intercepts. That it means how many times does this parabola cut the x-axis? There are 2 solutions right here. These are the solutions. So we have 2 real solutions, right? Because they're real. How many? 2 real solutions. Because they're on the real number line. What is the x-intercept, or what are the x-intercept? Right here, we just found them, 6, 0. And please don't put union. I've noticed people say put union. 6, 0 and 4, 0. You can put 4, 0. I normally say and, or I put this for and I think some may confuse this for union. It's not union. So I'm going to stop using that. It's an and. I'm going to stop using that and just write the word and. what is the y-intercept? Where does the, so y-intercept, if we keep going right up, where is this going to cut the y-axis? How do we know that? Now remember, when we said x-intercept, for x-intercept, the y value is 0, right? For x-intercept. For the y-intercept is going to look like 0 comma something, right? That's what a y-intercept looks like. It's got 0 for x. So take x equal to 0 and plug it into the equation. If you plug in 0 for x, this is gone, this is 0, this is 0, so you're left with 24. By the way, c, the constant, is always your y-intercept, right? Because when the x's are gone, you're left with a constant. So in this case, your y-intercept is 0 comma what? 0 comma 24. Which means this graph is going to cut the y-axis some way up here off the chart at 24 if you keep going up. Okay, that's your y-intercept. All right, now what is the domain? Because this is a quadratic, the domain is all real numbers. So we write domain colon, okay, and then negative infinity in parentheses to infinity. Okay, these are parentheses, so be careful with that. What is the range? The range is a y value. Range is from this y value. This is the lowest y value, which is the y value. Remember the vertex here, the vertex happens to be a minimum because we said the graph opens upward, so the vertex is a minimum. So the y value of the vertex is the lowest y value we can get to. So therefore the range starts at -1, including -1, which means bracket -1, and all the way up, which is going up to infinity. So this is how this type of graphing, right, well, solving by graphing, basically. So you graph, and notice that it all really revolved around the vertex. The vertex was central to the idea of, or is central to the idea of graphing. So the vertex, and then the table of 5 values, and the 5 points showing, and the connecting the graph, and then answering the questions. So remember this. This is part B. Part C, I'm going to skip around, and if you have questions in class, we'll talk more about this. I'll share this document on Canvas as well. Part C says solve by taking the square root. So taking the square root is the idea of taking the square root is to isolate something squared on the left-hand side equal to something here. And then from there, you unsquare or take the square root of the left-hand side, and the cost of this is to take plus or minus the square root of the right-hand side. Okay, remember plus or minus on the right-hand side. So let's try a couple of them, right? Let's try a couple of them, starting maybe with number, let's say number 1. Number 1, you subtract 5 from both sides. You get m squared is equal to 36. So that means m is equal to plus or minus the square root of 36, which is plus or minus 6. Now, this is nice because 36 is a perfect square, right? So what are you saying here? You're saying these values, 6 and -6, will make this equation equal to 0, right? Or will make left-hand side equal to the right-hand side. Technically, that's what it means. Let's try something else. Let's try number 2 is easy also. Add 1, add 1. You get 2m squared is equal to 50. Then divide by 2. Remember, you have to get something squared, the item squared. You cannot have 2m squared. You're not solving for 2m squared. You're solving for m. So you need to get rid of the 2, and that gives you m squared equals 25. And therefore, m is going to be plus or minus the square root of 25, which is plus or minus 5. Okay. For number 4, for instance, again, you add 12. Remember, when you're solving for a variable, in this case, you want to work from far to near, meaning the -12 must go first. So you're adding 12 to both sides. This gives you x plus 7 squared, quantity squared, is equal to 12. And then you take the square root, right? When you have, remember, we said when you have the quantity equal to squared, then the next step would be to take the square root of this, and then you take the square root of this, right-hand side, with a plus or minus, which means the left-hand side is going to lose its square, and that'll give you x plus 7 equals plus or minus the square root of 12. And then you subtract 7 from both sides to get x by itself, right? Now, a good way to write this is to say -7 plus or minus square root of. Some may ask, Mr. Y, could I have written plus or minus square root of 12? and then minus 7? You sure can. My only concern with that is that you may accidentally, or some may accidentally extend the root, the radical sign, and include the this negative 7 underneath it, which would be wrong, okay? So either way, that's why I prefer having the constant here, the radical term here, and then the plus or minus after, right? Plus or minus the square root after. So either way, it's fine with this being my preference. Okay, so moving on. Now, if you look at number 7, just to try something a little bit different, notice that you're saying a quantity squared, right, is equal to a negative value. Can you square a number and get a negative? Not in the real world, not in the real, not with the real numbers. So here, when you see a quantity squared equals to negative, you will automatically say what? No real solution. Don't say no solutions, because we have solutions. We haven't learned them yet. We just don't have real solutions. That means solutions that are on the real number line. We don't have that just yet. We don't have real solutions, but we have different types of solutions. And I had mentioned something about imaginary solutions in class, right? But we haven't gotten through this yet. I'm going to go more in detail later. So this is 3C really. Moving on, let's try solving using the quadratic formula. Remember to memorize the quadratic formula, right? And it is x equals, remember the song? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so just remember that. It helps, right? It's a song that helps you remember the quadratic formula. Now this is the quadratic formula, right? The quadratic formula. What the quadratic formula does, it helps you solve the quadratic equation. Remember, this is the quadratic equation. So this, the ax squared plus bx, these are equations, plus c, it's an equation. The quadratic formula, this, helps you solve for that, okay? So I would automatically, again, the deal is, I would automatically identify a, b, and c. Oops, a, b, and c. A is 2. A is the leading coefficient, which is 2. B is the coefficient of the linear term, which in this case is k, so it's negative 5. And c is the number, the constant, the number by itself, basically, which is 2, positive 2. So to apply the formula, remember normally we say x equals. In this case, the input or the independent variable is k. So we say k equals negative b, the opposite of b, which is positive 5, plus or minus the square root b squared minus 4ac, all of that over 2a. So 5 plus or minus the square root b squared. B squared will always yield a positive or 0. It will never yield a negative. So this is 25, this value. And then negative 4, or times 2, that's negative 16. Right, 4 times 2 is 8, 8 times 2 is 16 with a negative. All of that over 4. So it will be positive 5, or 5, plus or minus the square root of what? Square root of 9. Over 4, which is 5 plus or minus 3 over 4. So how do we deal with this? When you have here you have all integers, right? So you have two answers. When you say plus or minus, you have either 5 plus 3 over 4, which is 8 over 4, which is 2, or you have 5 minus 3 over 4, which is 2 over 4, which is 1/2. So what are we saying here? We're saying the values 2 and 1/2, or 1/2 for k, make this equation 0. So that means if you were to graph this on the xy axis, in this case, this would be the k axis, right? K and y, or f of x. Y would be f of k, right? There's k here as your independent variable. This is saying at 2, you're going to have a 0 or a root. You know, the graph of this parabola is going to cut the k-axis, right, at 2, and also cut it at where? Is it 1/2 or negative? Yeah, 1/2, sorry, it's 1/2. This is 1, 2, at 1/2 right here. All right, that's what it means. So we're finding the values where the parabola cuts the x-axis or the k-axis, whatever the independent variable is. This is what solving is, right? All right, which means where the y value is 0. So, so basically, that's how this works. Now, another part of this, again, before you do the quadratic, I will not solve number 4 or 2, but I want you to know that before you do quadratic, you have to put things in order of ax squared plus bx plus c equal to 0, right? You want to have equal to 0 on the right-hand side. So for number 4, just a pointer, it should be 2x squared plus 12x, and you want to add 15, right? You want to add 15 to both sides. So you want to get plus 15 equal to 0. And then you say what a is, what b is, what c is, and you solve. And same for 2, okay? You want to move these guys to the left. So you're going to add b, and you will subtract 3 from both sides. You're going to add b and subtract 3. So you get 5b squared plus b minus 3 equal to 0. And then, again, what a, b, and c are. Okay, I don't like when they give you b as the variable, because that may confuse this b as the input with this b. They're different. This b is the leading coefficient here, which is 1. Okay, so this helps. Now, the second part of this part, which is part D, is the discriminant. Remember, we talked about discriminant in class, and a quick review on the discriminant. The discriminant, first of all, is the b squared minus 4ac term. So if you remember in the quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. The term under the radical, this guy, just this guy, the b squared minus 4, without the square root, okay? Don't say square root of b squared minus 4ac. The discriminant is just this, without the radical. So that tells you a story. And the story is, if b squared minus 4ac, and we said this in class, we went over this in class a couple times, or several times actually, we end up with 2 real solutions. If b squared minus 4ac is 0, we end up with 1 real solution. And if b squared minus 4ac is negative, we have no real solutions. What does this look like really graphically, right? When you have, and I'll deal with each case separately, when you have 2 solutions, you have a graph, you have a parabola that looks like this, or it could be upside down, it doesn't matter. But the point is that what? The point is that it's going to cut the x-axis at 2 different points. That's what 2 real solutions means. When you have 1 real solution, right, 1 real, your graph is going to look something like this. It will be tangent to the x-axis, right? It could also be like this somewhere, okay? And this is normally when you have like x minus 1 squared equal to something, right? So this is 1 real solution. And no real solution, the third and last option here, is when your graph does not cut the x-axis. It does not meet the x-axis. It could be something like this or something like that. Okay, so just be careful. Understand the meaning of this. Not like 1, 0, 1, or no real. Understand what they mean, what they actually mean on the graph. Okay, 2 real solutions, 2 points of intersection, 2 values for x when you solve. 1 real solution, 1 point of intersection, 1 value for x. No real solutions, no points of intersection with the x-axis, no values for x, okay? So for number 5, real quick, it says find a discriminant. I could choose any one of them. First, again, first things first, I need to write everything in order from all things to everything to the left in the equation, which means I'm going to subtract 4, and 0 on the right-hand side. Remember, you're going to subtract 4 from both sides. From there, I'm going to find b squared minus 4ac. B squared, this is b, here 6. 6 squared minus 4ac, right? Because here, a is, again, I don't like that they use a for a variable, but a is the leading coefficient, which is -5, b is 6, and c is -4. So b squared is 6 squared minus 4 multiplied by -5 multiplied by -4. 6 squared is 36. Now, the easiest way to determine here, because you have negatives, multiple negatives, always think about how many negatives we have, right? If we have an odd number of negatives being multiplied, the answer is negative, because negative times a negative is positive, times another negative, third negative is a negative. 4 times 5 is 20, 20 times 4 is 80. So this is 36 minus 80, which is -44. And because this is a negative value, the b squared minus 4ac, we're here. We're at no real solutions, right? So to answer the second question, how many solutions? We say what? No real solutions. Okay? So keep that in mind. And so on. Again, move everything to the left first, equal to 0, and then solve. For number 6, just a hint here, a pointer, you don't have a c. You have a is 9, b is -24, and c, when you don't have c, or we don't have sometimes b, that is 0. Just use 0 for it. So technically, you're going to do b squared, which is -24 squared. Remember, we put the value in parentheses, minus 4 times 9 times 0, the 4ac. Because c is 0, all this will be 0. So you only get 24 squared, right? And 24 squared is 480 and 96, 576. Okay, so you have one value for b squared minus 4ac, one value, right? Which is actually one value, sorry, that is positive. Scratch that. One value that is positive, right? So you're here. You're here. So this is going to give us what? 2 real solutions. And so on. If you end up with one of them being 0, then you get no solutions. Okay. So yeah, here, I should have said 2 real solutions. Okay. Let's take a look. Sorry, let me clear that. 3E. CTS is complete in the square. Okay, that's what it means. So this is a new skill. To complete this square, if you recall, we had 2 parts. We had a part where a is equal to 1, like here, a is 1. And the other part where a is not equal to 1, like here, the a value is 3, right? So I'm going to discuss each one of them separately, and I'll do that for each one of them. To complete this square, first of all, you need, when a is equal to 1, you need to find b over 2 and square that number. So b over 2 is, in this case, is 3 over 2. And if you square 3 over 2, you get 9 over 4, 9/4. So 9/4 is the value that completes the square. Now, what does this mean? What's the perfect square? Completing the square means take it from this standard form here, right, to a perfect square. So what perfect square is this? It is x plus, again, this x squared is x, this 9/4 is 3/2, and then the middle term is positive, so this is positive. Okay, so x plus 3/2 squared. Okay, now here a is not equal to 1, but I'm going to do this differently. I'm going to factor 3 out, right? Because I can factor 3 out of this and this. So this becomes, this is a little bit more work, this becomes 3 times x squared minus 6x and then I'm adding something to it, right? Now here's the deal. What do I add? How do I do? I have b, my new b, this guy, right? The new b is -6. If I do -6 over 2 and square it, that'll give me -3 squared, which is 9. Okay, this is -3 squared, which is 9. So if I add 9, inside, so let me just write this a third step here. If I were to add 9 to this value, it will complete the square, right? But adding 9, just be super careful with that. But adding 9, what am I actually doing, right? What am I really doing? I'm adding 9 to the inside, which means I'm adding really a 27. I'm adding 3 times 9. So if I add 9 inside of this, right, I will be adding 27. How do I compensate for this? And by the way, this here, I don't know if this meant like the right-hand side. I think this meant what is the result of this, right? So if I add 9, I'm adding 27. To cancel that out, to make it look like I have not added anything, I'm going to need to take away 27. So this here becomes 3 times my perfect square, which is x squared minus 6x plus 9, which is x minus 3 quantity squared. Let me clean this up a little bit. X minus 3 quantity squared, and then what, minus 27. So this becomes 3 times x minus 3 quantity squared minus 27. Okay, so I almost turned it, well, actually, I did turn it from a standard form to also a vertex form by doing that. So this is the difference between when you have a equal to 1, and you can automatically do b over 2 squared, quantity squared, versus you have to factor 3 out. And when you do that, then be careful. Whatever you add here to complete the square, it's going to be multiplied by this number. Now, this is how it works in generally, right, with expressions. But with equations, you're going to see that when a is not equal to 1, here, with 3x squared minus 8x, we added and subtracted 27, basically. With when you have equal to 0, instead of adding and subtracting, let's say 27 from the same side, you add 27 to the right-hand side of the equation, and then you add 27 to the left-hand side, right? And that's the same thing as adding and subtracting from the same side. So let's try it. Let's try it so you can see how that works. I'm going to try 1 and 3. For number 1, b over 2 is 4 over 2 squared. 4 over 2 is 2 squared is 4. So 4 is the number that needs to be added. Where does it get added? Where do I add that 4? I added right after the linear term. I added right after the x to complete the square for the first 2 terms, right? So that I can get a perfect square trinomial. But then drop the -6. And then because I added 4 to the left-hand side, I'm going to add it to the right-hand side. Notice that if these guys did not exist here, which is adding 4 to both sides, I would get exactly what I had originally, right? So this is the idea. Again, you're going to add 4. You're going to add this b over 2 squared. Where? You're going to add it right after the x term. So x squared plus 4x, and this is where you drop the b over 2 quantity squared, the number that you just got from here. And then now you find your perfect square, which is x plus 2. So the first 3 terms, these guys are x plus 2 squared. Then you have -6 equal to 4. To clean that up, you add 6 to both sides. It says solve. So I'm going to solve. I'm going to add 6. I get x plus 2 squared is equal to 2. 6 minus 4 is 2. Then you solve by basically, so you complete the square first, and then you solve by taking the square root. So you get x plus 2 equals plus or minus the square root of 2. And then by subtracting 2 from both sides, you get x equals -2 plus or minus the square root of 2. And these will be the 2 answers. Now, let me try 3 or 4. Let's try 3, for example. So first for 3, let me clear this and see if I can move the page up a little bit. Yeah. For 3, you have again to write it as ax squared plus bx plus c. So add 8x and subtract 45, right, to both sides. And this will give you 2x squared plus 8x minus 45 equal to 0. And doing so, now you have a not equal to 1, right? A is equal to 2. So you can factor 2 out from the first 2 terms only. Just remember that. We're only factoring because you're completing the square for the first 2 terms. And then negative 45. This is what you do. That's step 1. Step 2, you're going to find b over, this is your new b over 2. So 4 over 2 squared, and that's 2 squared, which is 4. So 4 needs to be added inside the parenthesis. But again, by adding 4, which will complete the square, I'm really adding 2 times 4, which is 8, right? And again, copy this now. So again, I'm adding 8. So I need to add 8 to the right-hand side to balance the equation. Now, what is my perfect square here? I have 2 times x plus 2 quantity squared, and then minus 45 equals to 8. Add 45 to both sides. You get 2 times x plus 2 squared equals to 53. Divide everything by 2. I'm gonna just write it here. Then you get x plus 2 quantity squared equals to 53 halves. And then you take the square root of both sides. X plus 2 quantity squared is equal to plus or minus the square root of 53 halves. And then subtract, you end up here. This is gone, right? Because we took the square root. This 2 is gone. The square is gone, basically. And then you get x equals negative 2 by subtracting 2 from here. Plus or minus the square root of 53 halves. Okay. Now, I don't like the 53 halves being in the radical, and that should be rationalized. But that's fine. If you keep, I think for now, if you keep it like that, that's fine. But normally, you don't keep a radical in the denominator. So this is the same as saying square root of 53 over square root of 2, right? It's the same as saying that. So what do? You multiply top and bottom by square root of 2 to get rid of the square root of 2 in the denominator, because you're not allowed to have a square root in the denominator. So this becomes square root of 106 over square root of 2 multiplied by square root of 2 is just 2. And that's pretty much it. So this could be written as I have it here, or even better, negative 2 plus or minus the square root of 106 over 2. Okay, so this is solving by completing the square. Make sure you take notes on this. And let's see. Okay, so I'll pause here for now. We'll talk more about this so that the video is not too long. I'll pause here for now, and we'll talk about the rest of this in class. There's completing the square part 2, which is similar, really. And then if you have questions on applications of quadratics, right? Actually, maybe let me do one of the rest. Okay, let me do one on applications. Let's see, if we have 2 of them, I'll do one. Yes, let me do number 1. Let me just jump to 3F and do the first one. For number 1, it says a toy rocket is fired into the air from the top of a barn. Its height h above the ground in yards after t seconds is given by the function h of t equals negative 5t squared plus 10t plus 20. What is the height of the ball after 3 seconds? So when they say what's the height of the ball after 3 seconds, they're really asking you for h of 3, because they want t, the time, to be 3 seconds. So this becomes negative 5 multiplied by 3 squared plus 10 multiplied by 3 plus 20. And this is 3 squared is 9. Negative 5 times 9 is negative 45 plus 30 plus 20. 20 plus 30 is 50 minus 45 is 5. So the height, h of 3 is 5. The height at 3 seconds, that's what you're saying, right? The height at 3 seconds is what? 5, whatever the units is, yards. 5 yards. Now, that's the first part. What is the height of the ball after 3 seconds? What was the maximum height? When they say maximum, when we talk about the language, remember this is a quadratic. So when we're talking language of maximum or minimum, this is basically implying the vertex. This is referring to the vertex. Notice A is negative here, right? A is negative 5. That means your graph is going to be this way, downward, opening downward, and therefore you'll have a maximum, right? So to find the maximum height, we first need to find the x value of the vertex, which is negative b over 2a. So it's negative 10 over 2 times negative 5, the opposite of b. So that's negative 10 over negative 10, which is 1. This is the t value, which is the time. So first you find the negative b over 2a, which is the x value of the vertex. In this case, we don't have x. The input is t, right? And the output is h of t, the height at t. You don't have x and f of x. You have t and h of t. So we find first the t value, the input, which is the time, 1 second. And then you take that and plug it into the equation. You find h of 1, right? So the height at 1 second, and that's going to be negative 5 times 1 squared plus 10 times 1 plus 20. This is negative 5 plus 10 plus 20, that's 25. So you have technically, after 1 second, this is, you're saying after 1 second, the height is maximum at 25 yards. That's the maximum height. At what time, they're asking for a time. Remember, in our unit, and normally up to this point in Math 1 and Math 2, basically, all you've done is x and y, or t and f of t, right? So you have two variables, and normally you're given one and asked to find the other. Here, they're asking you at what time. They're asking you for t. If they ask you for t, they need to give you h, the height. So there it goes. Will the rocket be at a height of 22 yards? So in the equation again, you're going to replace the height by 22. You're going to say 22 equals negative 5 t squared plus 10t plus 20. And this will be what? This will give you, now you have to solve for this, right? You have to solve for t. So how do we solve? I personally would move, I don't like having a negative coefficient in front of or to the left of t squared, which is the leading coefficient. So I'm going to move everything to the left. So I'm going to add 5t squared, or you can multiply by a negative, it's the same thing. Subtract 10t and subtract 20. So 5t squared, subtract 10t, and then subtract 20, and then plus 22. So this becomes 5t squared minus 10t minus 20 plus 22 equal to 0, which means 5t squared minus 10t, negative 20 plus 22 is plus 2 equal to 0. And then you can solve whichever method you want. You can do the x method and try to factor, and you can do the quadratic formula, which is easiest probably. So let's try that. Again, we say normally x equals, so I'm going to do the quadratic formula. Instead of x equals, here we have t equals negative b, the opposite of b, which is 10, plus or minus the square root of b squared, negative 10 squared, minus 4, a is 5, c is 2. 4a, c. All that under the square root, all over what? 2a, which is 2 times 5. So t equals 10 plus or minus the square root of 10 squared is 100. Negative 4 times 5 times 2 is, that's going to be negative 40 all over 10. So you'll get 10 plus or minus square root of 60 over 10. Now, how do you know what the square root of 60 is? 60 is not a perfect square, but it's a composite number. So you can take 60 and break it up, right? Into 2 and 30, 2 and 15, 3 and 5. So 60 is basically the product of these prime numbers. 60 is 2 multiplied by 2 multiplied by 3 multiplied by 5. And to take the square root of 60 is basically taking the square root of the product of these numbers. And remember, square root, every 2 become 1, 2 on the outside. And whatever's left on the inside gets multiplied. So it's 2 root 15. So this is the same as saying 10 plus or minus 2 square root of 15 over 10. We talked in class about cleaning things up. When this number, and this number have something in common, then we can factor that out or divide it by this number. They're all even, 10, 2, and 10. So divide everything by 2, you get 5 plus or minus 1 root 15, or just root 15 all over 5. These are really your answers. Now here you have to, I'm going to just add something to this, right? Before going to part D and wrapping up. You have to be careful with word problems. Word problems always have context in them. And here you're finding t, and t is a value of time, right? It's a value for time. So time cannot be negative. So you have to be careful if any of these two values are negative. I know 5 plus root 15 over 5 is not negative. This is positive, so it checks. 5 minus root 15 will also be positive, because root 15 is less than 4, because 15 is less than 16. So this is going to be something like almost 1/5, right? Or nearby 1/5. So this is also positive, we're good. However, in some questions, you may end up with one value that is negative. And if the context is time, then what you would do is you would reject that value. But we'll talk about that later. This is like a way ahead warning, okay, about this kind of problems where you have context of the variable. Generally speaking, when we dealt with this as an equation without context, without knowing what's going on, we accepted any value, right? We said these are the two answers. But here, because we're talking about time, right? So the value may not be negative. Part D, but here we're safe, okay? With the two answers, we're safe. Part D, it says, after how many seconds, so again, we're looking for time, will the ball hit the ground? What happens at the ground? At the ground, when they say hit the ground, this is an indirect way of saying the height is 0. They're saying indirectly, plug in 0 for h. That's what hit the ground means. So what you're doing, you're going back to the equation, which is negative 5t squared plus 10t plus 20, and you're saying, I'm going to make this equal to 0. That's what it means. Okay? So here, what you could do, I noticed that, and I could have done this earlier. I noticed that there's a GCF. I can divide, because when you have equal to 0, you can divide both sides. So here I can divide both sides by -5, or I can factor a -5 out. And if I do factor a -5 out, I'll get -5 times t squared minus 2t minus 4. This is the original, okay, equal to 0. And then by dividing both sides by -5, I really get t squared minus 2t minus 4 equal to 0. So then I can solve. I can try to factor and see what two numbers multiplied to -4 add up to -2, which I don't think any of them will. Or I can do the quadratic formula. I don't have room for that on the right-hand side, so I'll do it here on the left. So I can do the quadratic formula here, right? The quadratic formula. And again, it's not x equals, it's t equals negative b. I'm doing the quadratic formula for this equation. Okay. Negative b is positive 2 plus or minus the square root of b squared, which is -2 squared, minus 4, a is 1, and c is -4. All of that all over 2a, which is 2 times 1. So t equals 2 plus or minus the square root of 2 squared is 4. Minus 4 is c, -4 times 1 times -4, that's positive 16. Right? All over what? All over 2. So I'm getting 2 plus or minus the square root of 20 over 2. Now, square root of 20 is 4 times 5. And the square root of 4 is 2, so it's 2 root 5. So here I have 2 plus or minus 2 root 5 2 square root of 5, all of that over what? Over 2. So I have, again, I have 2, 2, and 2. They're all 2s, so I can simplify this. I can divide all of them by 2. So I would get 1 plus or minus 1 root 5, but I don't need to write the 1, over 1, and I don't need to write over 1. So these are my two answers. Okay, now here, again, we just mentioned context. 1 plus root 5, I get two answers. Either t is 1 plus root 5, or t is equal to what? 1 minus root 5. That's what the plus or minus here mean, right? What does that mean? What does it mean? 1 minus root 5 is a negative value for t. So if this was graphed, you'll be at the ground somewhere here maybe. Negative root 5 is 2 point something, right? 1 minus that is negative 1 point something, so it's a little bit left of 1, negative 1. And 1 plus root 5 is a little bit past 3. So this is 1 plus, this point here is 1 minus root 5. And this point here is 1 plus root 5. So you're saying the ball hits the ground at these two times. Now, context-wise, the ball could not have been at a negative time, right? So your graph is basically something like this. So it could be the case that we started timing here. When we started timing, let's see, a toy rocket is fired into the air from the top of a barn. Remember? So this did not start at 0. It didn't start at the origin. This is the top of the barn right here. We started firing from here. So whatever that value is, we started firing from here, and what happened? It just dropped down. Now the left-hand side here is hypothetical. It's like saying, what if we took this back in time, right? It would have come from this value, which is not possible in terms of time, because time cannot be negative. So where is the only value that we accept is what? So from the top of the barn, it went to the max here somewhere, and then it dropped back down, and it landed on the ground at what? So we're going to reject this value, negative value for t. We're going to accept this value. Okay. In context of the question, that's how it works. So I hope this was helpful. We technically did the entire unit by doing this in about an hour, which is good. So good luck to you. Try to, in class, I'll pass this out. I'll put it on Canvas as well, so you can take a look at it and do more of these questions, because they're good practice. And if you have questions on this, please ask away. And I'll also see you in class, and we're going to go over a review to prep you for the upcoming test, which will be on Tuesday. Good luck to you, and thanks for watching and listening. Have a good one.